aspects that sometimes I have read on social media in the past, that eventually you student athletes, okay, and maybe people with playing musical instruments will continue to do that after high school, and that's great. But for the majority of you, chances are, if you are a student athlete, your senior year is probably maybe your last time playing competitively. Doesn't necessarily mean it is, it just means that it's possible. Because I think for those of you who do go on to a 4-year college, I think what a lot of students say that are at a big university, it's probably a lot more enjoyable in what we call intramural sports. Does anyone think they know what that is? What would intramural sport be? Just take a guess. Just for fun. You just show up the rec center, recreation. That's what it means, the rec center, and you form your squad or team of, in this case, maybe 1, 2, 3. Because I know it's you, 3 basketball players, and I don't know. You just have to pick 2 more, and yeah, you just go out there and you have fun. If you win, great. If you lose, you could probably not care less. Maybe yes, maybe no. But some of you, as far as going on in the 4-year universities and colleges, again, I can't stress that enough. What we're going over now, if you have a really good understanding of that, you're really setting yourself up for success. Okay? And I know you individuals are, I don't think anyone's still 13. It's either 14 or 15, correct? I mean, in general, okay? I would find it very hard to believe that some of you have your career path already chosen. I mean, some of you may think, well, this isn't important. I'm just going to go be a diesel mechanic or an electrician, and I would find that hard to argue. That's great, but again, for the rest of people who really do need to, let's say, understand this, is I think that would be selfish to be a distraction for them. And I'm not saying anyone in here is. That's not the issue. But and some of you maybe do enjoy learning things like this, because one of the things I think that's kind of neat to do, we'll do something very similar to what the juniors are doing in general chemistry. Is when you look on that assignment board, what they have for Tuesday, it's called a limiting reactant percent yield activity. And what that means is you take 2 substances and you have a chemical reaction that takes place, and you try to predict on pencil and paper how much of a material you should produce. And they'll wrap that up today, and it hopefully reinforces the materials that it is that you're learning in here. And I know, I get it. There's probably some other place you'd rather be. Some of you may wish you could have English maybe twice a day, more English, maybe more math. Just science just isn't your thing. Maybe yes, maybe no. But again, for some of you student athletes, scholarships can take you quite a ways. When I was student teaching, it was a Davis girl was her name, and she was a sophomore when I did my student teaching at Tri-Valley. She went to play basketball at SDSU, I think. They were still Division II at that time. They weren't Division I. And then I think she went on. She's an optometrist now, I believe. So sports, yeah, I know it's not as important what we're doing in here, but in certain cases it can take you places and pay for some of your tuition. And I just remember having her as a student. She was a he was a great basketball player, of course, and that took her places, paid for her tuition up at SDSU, and like I said, is now an optometrist, if I'm not mistaken. So, because chances are, and I would say this to other students, whether it was last year or 2 years ago, one of the things I would tell other people, I said, gosh, I can see why our football team is really that good, because especially 2 years ago, who were your leaders out there on the field? One was a senior, the other one was a junior, out on the field, not on the sideline. That was one. No. One was a junior, that would be Bodie. The other one was a senior. No. Say that again. Malik, definitely. And maybe I'm being biased using those two as examples, but I would tell people I can see why they're so good out on the field, because those two individuals were they're really smart. And in certain cases, maybe athletics took them places, but I think and plans do change. Because chances are, if you really know what's going on in here, you can probably dissect a playbook pretty easily and know what you need to do. Same thing as far as looking at music sheets or memorizing pieces in as far as the being on the stage. You're just really setting yourself up for success. And again, I know this isn't for everybody. But anyway, this is one type of bond we see here. What is the other type that we have discussed? The covalent type bond, okay? And what's true about all of these over here? This is kind of maybe a slight exception, but chlorine, iodine, this would be ethane, and this is ethine or acetylene we talked about yesterday. Each and every one of those is a covalent bond, because what is the major difference we talked about? That ionic bonds do what with their electrons? They totally give them away, okay? And then covalent bonds means they are sharing. Okay, so as we continue. So in elements, yeah, they're in column 1 or 2, okay? They will give their electron away, okay? That means it has to have a place to go, so maybe a potassium atom is giving away its lone electron to that of a chlorine atom. Just make sure you don't get on the bad side of this young lady, because she has her potassium chloride. But that's not to take anything away from this year's football team. Those seniors and juniors, they're still pretty smart too. But some of them chose not to be in here, but that's fine. That's okay. Because science isn't for everybody. When we say it isn't for everybody, who's that in here? We can be honest. Okay? Just 2? That's it? 3? Okay. All right. Fair enough. So, and we've done an example like this, and for those of you who had watched that presentation, okay, we basically did some of the problems on your paper, because one of the things that we had said yesterday when we did this chlorine molecule, we said the only difference between these two is you just basically have to change the letter. Why would that be if you're talking about chlorine and iodine? The only thing you have to change between these two is the letter. Because what column are they in? In the 7th column, So that means they're going to have maybe not quite identical properties, but very what? Very, very similar properties, just like those in column 1. They're not going to have identical properties, but very, very similar types. Okay. And when we're talking about the zero net charge, that's where we're finding the least common multiple so that all charges add up to 0. So, as we continue to move forward then, so we've talked about ionic bonds. We've made reference to what covalent bonds are. So, what happens in a covalent bond is we are sharing those types, sharing the electrons. So there are 3 places. Well, it's on either the left or the right side of this screen. Okay, so you can see over here and over here. Okay, what would some examples be of a molecule? Well, look at what it says: a neutral particle that forms as a result of electron sharing. Okay, so when we're talking about a molecule, it's just 2 elements only. So, what are the 3 molecules that we see up on that board? No. Iodine's 1, chlorine's 2, and oxygen's 3. Okay? So, what we see happening with those, the iodine and the chlorine share how many electrons between them? It's in column 7, but between the two, what did we do yesterday? Is how many are in between, floating back and forth? Okay, so there's 2, but one an X from one chlorine, then maybe a dot or a triangle from the other chlorine. So that's what we mean by a single bond. This will make more sense here in just a moment. Okay. So the main difference, again, some of you may help elementary students. And this is one of the things I always like to do is, and I did that with the sophomores yesterday, I'll do it with the juniors and seniors. Elementary student walks, because I've seen you individuals go down to the elementary, so you help out elementary teachers. So could be such a thing, third grader, second grade, what grade? Oh, it wouldn't happen in first grade, but probably not second grade. But we're going to say it is. Gosh, I don't know, what is a molecule? Well, you can help them out by saying, what? What are the electrons doing with one another? Are they sharing or not? Yes. Yes, they are. Okay? So the difference between that covalent and ionic bond is one completely transfers it. Okay? Then the other one, they share them. Okay? One of the things I like to do, because I think it's kind of funny, because it was explained to me this way, and maybe it is or isn't right, but one of the things you could look at is, okay, here are the pretty gals right here. Okay? And the rest of these are the guys right here, because, for instance, elements 19 and 20, besides the lettering, the atomic masses, and the atomic numbers, between elements 19 and 20, what would be the biggest difference between potassium and calcium? Okay, so you take what you two put together, because the +2 charge results from being in column 2. It has 2 valence electrons. So all the guys have $5 bills in their pockets going to the movies, right? You know, if you're taking your date to the movies, well, they got to have popcorn, don't they? Well, yeah, you got to go have popcorn at a movie. So then what do? So who can I pick on, ladies? Okay, so who can we pick on for the guys? Who? Okay, so then, all right. So you're up in Brookings or down in Sioux Falls at one of the movie theaters, and she says, "Gotta have popcorn." Well, kind of think, well, you just reach in and pull your $5 bills out because you just have all them to donate, right? Well, what kind of date is that? I guess it's a cheap one, okay? But we're still saying, okay, so pulls out $5 bills to pay for that popcorn because you can donate it. So the ladies are grabbing those electrons or those $5 bills to buy their popcorn and pop. Isn't this sounding familiar, guys? Oh. Well, look around. You got people you can date in here? No? Okay. All right. But that's an example. The guys, you have all that excess money, just like valence electrons, and ladies are willing to grab them and take them in so they can buy their popcorn. No? Okay. But it's got to be warm, though. Well, no wonder movie theaters can't make any money. Yeah? Sure. Okay. Moving on. All right. Okay, we've had our fun. Okay, moving on. Okay. those of you who are paying attention, this would really help you out here too. Because there's a diatomic. Why is hydrogen diatomic? Because it's a what? Because if you said oxygen's diatomic, we know that's a gas. Hydrogen's no exception. It's a gas, so it's also diatomic. Okay? So hydrogen is by far the simplest covalent bond there is, because there's only 2 electrons. It only takes 2 to make a bond. So if you see 2 hydrogens, you just put an E and an X between the 2, or a dot and an X, or a triangle and an X. You're done. Very simple. Because, again, hydrogen in column 1, it only has 1 electron to give away. Okay, I will come back to this, so don't worry, I will back up. Okay. We're almost done getting through what I want. All right. Somebody's ponytail holder. You still want it? Okay. Okay. Does everyone have this information that wants it? Okay, so one of the things we say, water kind of doesn't play by the rules of chemistry, which it doesn't really. It's kind of a unique molecule. For one, it can conduct electricity, which is kind of unique for a liquid. But and I can't think of this right off the top of my head besides water. It does something really strange when it freezes. Yes, most materials will constrict or contract or get smaller when they get colder. Okay? But water, on the other hand, doesn't like to play by those rules. It would rather expand or get bigger when it freezes. Okay? And it is rather unfortunate, especially when it comes to livestock. Okay? Cattle farmers, where are we at? Okay? So with that, do you have really nice cattle waters? Are they yellow and red in color? Okay. Does anyone know what I'm getting at? What brand of waters are red and yellow? Say that again. Ritchie waters, that's right. And one of the reasons that they're probably really nice because they have lots of insulation in them. Okay? Because should it be really that cold outside and your cattle waters are frozen, okay, what can happen is as you go further under the ground that supplies that water, if that line breaks, it's not going to create a mess until it unthaws, and then you're really going to have a mess. Okay? I distinctly remember these were called Bauman waters, I think. And at the time, they were probably really top of technology of what it was. It was made out of cement, and it had some insulation to keep the housing unit warm. It had a heating element in there to try to keep the water from freezing. But that necessarily wasn't the problem. It was the line coming into that water that would freeze. Okay? For one of our, it was for the barn that we had. In that outside water, it would go up through a cement culvert, and oh, what a mess when that would freeze. One of the things that I think we had done, take the housing unit off on the side, plug the bottom of that cement culvert, and just start dumping hot water in there and try to get enough to stay inside to get that line from freezing and get it unthawed. And for anyone who works outside and it's cold and your hands get wet, you're nodding your head yes. That is awful, isn't it? Okay? So, for those of you who do work outside, in other words, not with water, but some of you farmers, you're outside, you come back in, your fingertips are just, it's almost like if they could scream in pain, you would not want to hear that. You're nodding your head yes again already. Take a guess, what's happening inside your fingers? It can, but what's starting to form inside your fingertips? Well, it's already cold outside. Our body is already composed mainly of what? Water. So inside them fingertips, what's starting to freeze? Your blood and different types of fluid tissue. And we already had said when that freezes, it starts to do what? Okay, so what's happening, those little ice crystals that are forming inside your hands, it presses, well, I shouldn't say presses, it expands the tissue inside your fingers, but when that freezes again, well, you got tissue that's hooked up to little nerve endings, and when they start moving, that hurts. So, and it takes a little bit of time. It would be my advice, you don't run straight to the sink and run hot water on them, do you? That's going to make it even worse, correct? Just run some cool water over it, and then some warmer. Do what? And it's probably going to burn for a little bit. That's true. Okay? All right. So, when it comes to multiple bonds, okay? Double bonds. Who can double bond? There's 4 of them, I think. Oxygen, sulfur, nitrogen, and carbon. Okay? So if those 4 can double bond, that's true. Eliminate 2 of them that cannot triple bond. Oxygen cannot. So, sulfur. Now you're down to those 2. Yes. So nitrogen and carbon can triple bond. Okay. So this is where we're going to stop for, go ahead and get this information down. So I'm just going to take a guess. Just, you alternate with older brother who has to go out and check the waters. Oh, he never does it. So you do. So why are you getting stuck with it? You're just too nice to say no? Or is it because you're doing what you're told? Or both? Might have to have a little chat with him, saying that's not fair, is it? Because you feel bad for your cattle. Because you want them to have a drink. Is it stock cows or feeder cattle? Okay. So, about what size are they right now? So, you tell me when to stop, how tall the back is. 500-600 pounds, I suppose. Somewhere around there. Okay. So, you get to go feed them. See, you get to. You don't have to go feed them. You get to. Yeah. Okay. All right. So a couple things. We'll be going over this again. Okay. So as we look at what we see up here, okay, one of the things that for those of you who are going into science, okay, now this is after high school. Now, I think we've had this discussion before. If you want me to take a pick, I would, and say 1, 2, 3, 4, 5, 6. Yeah. 7, 8, okay, 9, and if I'm not pointing at you, no offense, 10. Okay, so one of the things that happens, 11. So this is one of the things that if there's time that permits, we may just do an experiment when we get to the organic portion of this. Everything we're studying right now is inorganic because it contains elements other than that of carbon. But this is what we call an ester. And one of the things that when you look up at that top line, it says soap production, okay? One of the things that I talk about with the seniors, and this is something that maybe your grandparents didn't make their own soap, but it would be your great-grandparents probably did. And it's just what I want to say, an expression. For some reason, basketball just popped in my mind. And if you're one that shoots the ball, it would be one of those that, for some reason, you're off a night before. So then you don't want to shoot anymore. And that's what shooters go through. Sometimes they just don't go in, right? And then the next night, holy cow, it gets to be catchy. Now everyone's making them. But a saying to that would be, you're going to miss 100% of the shots that you don't what? That you don't take. Logic, right? So when we talk about living on the farm in the 20s, 30s, 40s, as compared to today, as far as cleaning your hands, especially this time of year when the flu season is around, if we run out of soap, we just maybe write it down on our grocery list, or if we're out, maybe go to 34 stop, which maybe yes, maybe no, or you just pick it up when you need it. Well, back growing up in the 20s, 30s, 40s, and probably even 50s, you would make your own soap, because when it comes to that of the pig, this is an old saying, just like shooting the basketball. When it comes to utilizing the pig, you use everything but the blank. I'd be surprised if someone had heard or knows what that is. Say that again? No. When it comes to utilizing the pig, you use everything but the blank. No, it's not an actual body part. It's a noise. You use everything but the oink when it comes to pigs. Okay? Because how many of you pork rinds? You do you know what it is though? Pork rinds? Yeah. But so explain to do you want to know what it is? It's the outer hide or skin, I do believe, of the pig. Now we say use everything but the oink. When your great grandparents may have been on the farm, after butchering the pig, they would probably take the fat. No. What do you mean by render it? Yes. See, render is the type of truck that he never wants to call. What's the rendering truck? Dead animals. Okay? So, yeah, he's right. Anyway, so the point I'm getting at, so your great grandparents may have taken this fat, you make it in that lard, just like what you say. Lye, L-Y-E, not L-I-E, that maybe some of you do. I don't know, I'm just going by how this class had started. Okay? So L-Y-E is a substance. It's basically a strong base. That's just the simplest way to put it. So when this fat gets boiled down, you take this lye, that's a strong base, and you create soap. But technology today, some of you maybe go buy certain types of soaps. Why? Because they smell better. The type of soap production that we do has no smell, it has no color to it, and not that that matters, but a lot of people choose different types of deodorants and different types of soaps because of the fragrances that they have. Well, back then, you really didn't have that type of technology. So what we do here is we take an organic acid and you react it with an alcohol and you get a compound similar to this, and those are known as esters, which are fragrances, and we'll get into that at a later time. I wanted to go over these molecules, but we just ran out of time. We'll pick up with this perhaps tomorrow, depending upon how the weather unfolds, and maybe we're going to be just fine. Okay. Yes. Okay, I'll be right there. We'll pick up with this next time.